Aloha, everybody. I'm Julie Wiskirchen from the authors team at Google here in Santa Monica. And today I'm very excited to welcome Susan Casey and Laird Hamilton. Susan is the author of the New York Times bestseller, The Devil's Teeth, A True Story of Obsession and Survival Among America's Great White Sharks. She served as creative director of Outside Magazine, where she was part of the editorial team that developed the stories behind the best-selling books Into Thin Air and The Perfect Storm, as well as the 2002 movie Blue Crush. She was also recently named editor-in-chief of O, the Oprah magazine. And today she's going to be discussing her book, The Wave, in Pursuit of the Rogues, Freaks, and Giants of the Ocean. And she's joined today by Laird Hamilton, who's featured in the book. Laird is known as the guiding genius of crossover board sports and has been hailed as the world's greatest big wave surfer. He's been featured in films like Riding Giants, and he authored the book Force of Nature, Mind, Body, Soul, and, of course, Surfing. So please join me in welcoming Susan Casey and Laird Hamilton.
Thank you so much, Julie, and thank you for inviting us, and thank you for coming out on the day before a long weekend. I love talking about this book, and particularly love talking about it with Laird here, and to people who I know have a deep appreciation for waves on a lot of different levels. A lot of the times I start off by answering the question that I get asked the most often, which is, why did you decide to write a book about giant waves? And there's a sort of a multi-layered answer, but the bottom line was, this is the most powerful force of nature on the planet. I mean, I would make that argument. I've made it with some scientists. I mean, you can't argue that the sun is more powerful, but when you see the aftermath of something like the 2004 Indonesian tsunami or the tsunami that just occurred in Japan, or if you see a 100-foot wave, if you're, I would say, lucky enough to see a 100-foot wave in your lifetime, you really don't have any doubt that this is such a powerful, powerful force that exists on this planet. And at the same time, what I discovered in my research was that scientists are really at a loss to fully understand it, to fully understand how these waves are occurring in the ocean in a number of different situations. And of course, it all tracks into our, I think, our very, very fledgling knowledge of the oceans in general. And here is our planet. It's 75% ocean. So I love the idea that there are still these things out there that are bigger than we are, and these things that we don't fully understand, we don't know about, and that, you know, inform our lives in ways that we may not even be aware of. One of the things that happened right at the beginning, I guess I started working on the book probably 6 or 7 years ago. It seems to take me 5 years to write a book. A lot of that is spent reporting, and I like to go in a very immersive way into my reporting until I feel like the subject really is part of my life. I'd like to maybe do it a little bit faster, but it's also really nice to be able to take readers in with a level of detail that you really only get if you're truly, you know, pardon the pun, immersed in the subject. But I recall seeing this article in the New York Times, and it was the front page of the Science Times, and it was called The Mystery of the Disappearing Tankers. This was maybe 5-6 years ago. And the story was about how all these really large ships were going missing in the global seas. And one of the quotes was that approximately 2 of them per week just vanish. And I was reading this, and I was thinking, how does a 1,000-foot ship vanish? I mean, this is a large object, and we can locate, you know, molecules and atoms and things like that. How does a ship go missing? And as I learned more and more about it, I realized that it was exactly what was happening. Their numbers were a little high, but still, I came down to the number of 2 large ships per month were going missing. And to me, that was just an astonishing fact. In particular, this one kind of ship called a bulk carrier. And what this eventually led me to was Lloyds of London and this understanding of what was happening, to these ships that follow wave models, that follow climate models, that are provided. They have the best science and the best information we can muster, but these models were not accurately depicting what was really going on in the ocean. In other words, we didn't know. We didn't know what was going on in the ocean at its most extreme states. So what would happen is these boats would encounter rogue waves. Waves, the scientific definition of rogue or a freak, it's kind of an interchangeable term, is a wave that's more than 2 times as high as the seas around it, and it can be as much as 4 or even slightly more. So this wave is like a 100-foot wave popping out of 30-foot seas. And this was something that science just said was impossible. It was completely impossible, and it shouldn't be be happening. And this is a lucky ship. This is a ship that managed to make it back. But these waves were doing these tremendous things to these giant ships. A rogue wave had hit the bridge. This is the QE2. Had hit the bridge, which is just below the flag up there in like 39-foot seas, and in 1995, there was an event that really changed things for the understanding of rogue waves, because for all the times that captains had said, the ones that lived to tell about it, hey, we saw this giant wave come out of, it was stormy, but then this thing came along, and scientists were like, and a lot of the times it was seen as a big fish story, or maybe an excuse for why something got broken on the ship, and there was no scientific proof of this, and it didn't make sense in linear mechanics of wave theory. It didn't make any sense. But then in 1995, on New Year's Day, there was an oil platform in the North Sea called the Dropner oil platform, and it was hit by an 85-foot wave that popped out of 38-foot seas, and it had a laser on the platform that captured it in very accurate detail, and even that probably would have been wiped away as a data spike or something if it hadn't actually hit the platform at 85 feet. So for the first time, here was proof that there really were these waves that could pop out. And then so it was kind of like, okay, now we know they're there. How is it that they're existing? And to date, there's still a lot of unanswered questions about how rogue waves occur. And I spent a lot of time hanging out with theoretical physicists and people who are trying to understand the sort of feedback loops and the non-linearity of some of these giant waves under certain conditions. And there are certain conditions under which they do understand how rogue waves form. And rogue waves, the book goes into great detail about them, and they're wild. I mean, they are really just a kind of a teetering monster of a wave. They're misshapen. They can be breaking in really deep water where they're not supposed to be breaking. They have these giant troughs at the base of them, which in nautical lore is known as the hole in the ocean. And they can come in sets. They can come from different directions than the prevailing seas. Like, they really are just waves that are not obeying the rules at all. And they do take out these ships. They break on top of them. They breach the hatches. The cargo holds flood, and the ship snaps like a pencil. And then, of course, there's another type of giant wave, which we've had two major tsunamis in the past 8 years. And anybody who's seen footage from these, it blows your mind at the power of it. A tsunami, of course, is a giant wave with a super long wavelength, travels across the ocean at jet speed because of this long wavelength. And then, of course, when it hits some sort of obstacle like land, the tail of the wave just keeps coming and coming. So it's one scientist said to me, if it's 100 feet, it's going to be 100 feet for 5 minutes. So that's a different kind of giant wave. And the mass and the power of that kind of water is just hard to overstate. There was this great quote from Colin Powell, who had gone to Indonesia right after 2004 and has said, I've been to war, I've seen complete devastation, I've seen it all, and I've never seen anything like this. One of my favorite statistics was in the book. I had something from the Journal of Coastal Engineering saying that it only takes an 18-inch wave to topple a wall built to withstand 125-mile-per-hour winds. And I remember when I sent that chapter in, the editor queried me back and said, surely you mean 18 feet? And I was like, no. As a matter of fact, it's 18 inches. And I remember in 2004, and this is another thing back to the question of why did I decide to write about these giant waves, I remember thinking, tsunami. Like, I sort of knew a little bit about what it meant, but I really wasn't clear on the whole thing. And how did 240,000 people die? And I think a lot of people were like that. It was like, what is that? But this is a regular feature of the ocean, and we forget. We have this sort of collective consciousness where we're able to forget these things fast. I mean, this is I love this woodcut. It's Lisbon. There was a giant earthquake and tsunami in Lisbon in 1755 that really erased Lisbon and rocked Western Europe and Northern Africa in a way that really upended life in those societies for a very long time, and all the buildings burned, and it was truly cataclysmic. And the scientists still look at the Western Iberian Peninsula as a place that they think will see a lot more activity. The other place that seems really troublesome in terms of tsunami right now is the Pacific Northwest. There's a fault called the Cascadia Fault that is almost a mirror image of the Sumatra fault. Of course, the whole Pacific Rim is kind of a patchwork quilt of faults. So scientists really have a close eye on that because it's overdue to release. It's done it in the past. 1700 was the last time it really had a good shake, and it's making all kinds of weird humming noises right now. So finding all this, and I'm leaving out little bits which I'll get to, but what I did was I set off on this odyssey to find out who can take me into these waves, who can tell me, and by extension readers, what is this like and what is this about. And 2,000 people have been to the top of Mount Everest, and it's not give or take, and probably on one hand I can tell you how many people have been around a 100-foot wave or on it and lived to tell about it. This is a woman who, Dr. Penny Holliday from the Oceanography Institute, the National Oceanography Center in Southampton, Britain, and her experience with 100-foot waves was another thing that got me really intrigued to write about them. I saw a paper that she had written, and it was about the most extreme waves ever scientifically recorded. And what had happened was she was on this research cruise in the North Atlantic, about 150 miles off the coast of Scotland, and in February, which is never going to be, beautiful and calm or anything, but they had just had no idea what they were in for. They had a series of depressions. They were getting wave forecasts that were kind of gnarly, but that's the boat. It's a real workhorse of a science boat. It's about 400 feet long, and it's been in some rough seas. But what they got, what was so unusual about what happened to them was it happened after the storms had kind of gone away. They were hit by almost 48 hours of a series of 100-foot waves just coming. The median wave height was 61 feet. And there were a lot of spikes way off that chart. And they know all this with complete accuracy because the ship had a wave sensor on it. It was ringed with instruments. So it really was like a floating instrument itself. And it recorded everything that happened to it. And it was absolutely nothing like the models. So the models that all the ships use, that all the recreational boaters use, that anybody who's going to see, that people are building coastal installations, oil rigs, etc., they are not accurate. And this was, again, another sort of very straightforward proof of that. So I went to Southampton, spent time with them. This is just, not what you want to see. I went to Lloyds of London, and because Lloyds of London has been keeping accurate models about what happens to ships and stuff since like the 1644 or something, and I figured they could tell me. And this is another part that really opened up the book for me. What I discovered was that Lloyds of London, they have these great archives where you can see all the stuff that happened to these ships, but they also made it really clear to me that, rogue waves, we're interested in rogue waves, but what we're really scared about vis-a-vis the ocean is climate change. And they have, if you ever have time, you guys in particular will appreciate this, go hang out on the Lloyds of London site. It's this treasure trove of science, really cutting edge science and interesting facts, because what they're doing is they're trying to evaluate risk. And so it's really colorful. It's like, should we insure the Siberian lion, or that is going on display in Las Vegas? I don't know how long do they live, but it goes on really huge tangents, and it's a really well done website. But they have supercomputers the size of tennis courts trying to figure out probabilities for climate change to understand where are the best bets, what's the most likely problems, and of course, as I began to sort of get into the world of giant waves, climate change played a very big role in what all the scientists were doing who were studying them. And it's very clear that climate change and giant waves go hand in hand, not only in the obvious way with sea levels rising and storms, potentially extreme storms, becoming more extreme as more energy is in the system, but I've met this crazy character, and they call him Disaster Man, but he's a very well-credentialed scientist who pointed out to me that during the last ice age, as the glaciers receded, as more water poured off the land into the ocean, weighted the tectonic plates differently, that's when you really got some action, volatility, earthquake, volcano. There are some volcanoes that are so sensitive that they only 1 degree of pressure or 1 degree of temperature will make them erupt. Some volcanoes only erupt during the spring. These things are super sensitive to change, and we never really think about that. So, of course, landslides, earthquakes, volcanic activity is the definition of some of the biggest tsunamis, the cause of some of the biggest tsunamis around. like the Storaga slide was produced by an underwater landslide about 8,000 years ago and basically created Britain. Britain was at one point attached to the rest of Europe. It was just this wild odyssey into the world of what we don't know about the natural forces that really govern our lives. And there were just, I kept coming across, and I really love to come across the weirdest of the weird. And this is the weirdest of the weird. This is this bay in Alaska called Latoya Bay, where there was a 1,740-foot wave. And they know exactly how high this wave was because it scalped the trees off the surrounding hillsides, and it was created by a landslide that was created by an earthquake. And what is also really, this is 1958, July 9th. What's also really great for a writer about this is that there's eyewitness accounts of that night and people who are in boats in that bay who are like carried over treetops and stuff and somehow managed to survive it. And as I uncovered the history of Latoya Bay, it was like a very dark history of all kinds of crazy wave activity. This is the place where the biggest waves in the world are kind of being quietly churned out. And a lot of the times no one's there to see them. Now, the main group of people in the book, and the group that I felt were the through narrative and the people that I spent the most time with, were the people who I believed understood these waves better than anybody, better than any scientists, better than any sort of theoretical understanding of waves. And this group is a group of men who created a sport called tow surfing, which I'm sure most of you have heard about. Laird and a lot of his friends on Maui experimented in the 80s and 90s trying to figure out how they could ride bigger and bigger waves, because at 50 feet, or even for most surfers less than that, it just becomes impossible to catch a wave that big. And that was the goal. How do we ride the biggest waves in the world? And this is what they're looking for, really. This is actually a character in the book that I call the magenta blob. And the magenta blob creates waves like this. And this is a picture of Laird at Jaws, the wave off Maui that he really pioneered, and Don Shearer, the safety and helicopter pilot, who is every bit as expert in his helicopter as they are on surfboards. And I was very interested to spend time with them because I felt like, unlike anybody else, they'd actually understood the force of these waves in a very visceral, personal way. So I moved to Maui and kind of, Laird couldn't get rid of me. I was like, everywhere he went, I tried to go. This is again a picture of Jaws, and for me to see these waves and to see people on them was the most humbling, incredible, and at the same time exhilarating experience. One of the things that people ask me all the time about the tow servers is, are they crazy? And I say, well, what they think is that sitting behind a desk is crazy. They're the most, far from having a death wish, they're the most alive people I've ever met. Another wave that I was fortunate enough to see was this wave in Tahiti. This is a picture of Laird in 2000, rode a wave that is still known as the heaviest wave ever ridden, which possibly you know this and possibly you don't, but the water in front of him is probably about 3 feet deep. And I don't think you can see the thickness of that wave, but I had a chance to go back to Tahiti with him on a very big day. It has strange hydraulics, this wave, and this is a picture that shows you how it sucks the reef dry. And I remember before I went there, I was reading up on the physics of this, and all I kept hearing was freakish. It was like hand in hand with Chopu was the word freakish hydraulics, and so here's an example of how freakish. So actually, this is the day that I was there. I'm in the turquoise, and the Chopu was again another experience of, you can see, I think you can see down here how shallow it is. I mean, there's places where the reef pokes through the water. And people have died there, and it is a very, very, it's a place where even some of the most intrepid big wave surfers really hesitate to go. Later that same year, there was a series of big storms, and I had a chance to see Mavericks go off on this day. That's Garrett McNamara. Mavericks, of course, up in San Francisco, it's also claimed lives. And the day that I was there, somebody died just down the coast at a wave called Ghost Trees. This is Ghost Tree. This surfer was about to get his femur broken in 5 places in the next 2 seconds. and then 2 crab fishermen, right about 50 yards away from the boat that I was on, capsized in this very bad visibility, and nobody could find them. And one of their bodies was found. The boat was never found. The other one they never found. So, seriously heavy stuff. And then we went on. We drove through the night into Mexico, and we went down to this wave called Killers off the coast of Ensenada, which was there that I saw one of the bigger waves I'd seen. It was about this size, maybe 60 feet, and it was really an interesting experience because what I got to see at that point was how differently they behave when they're that big. They kind of advance like a vertical wall, and I mean, I'll never forget that sight as long as I live. It's sort of the definition of terror. And then as the book was ending, I was finishing up my reporting in 2009, December, a storm appeared that looked like it was going to match the greatest swell of all time in our lifetimes, which was December 1969 in Hawaii. And so everybody went to Hawaii to see what would happen. I won't give it away, but that forms the epilogue of the book. So it is a kind of a constant hunt and a constant, as Laird will tell you, waiting, searching, preparing for that moment when that magenta blob comes. And one of the things I ended the book thinking was, what does the future hold for him? Because having spent all this time with Laird, I can tell you right now, I don't think he's even peaked yet at all. So he's inventing, and he'll tell you about it, more different, better, bigger, faster ways to ride waves. So I think maybe he can tell you more about this himself. Laird Hamilton. What's it like to ride a 100-foot wave? I know, I wrote 100,000 words about it.
I know. I mean, it's hard to explain what it's like to, first of all, to be in those kind of conditions and to see it. But, I always describe it like the opportunity to see a dinosaur. They're dead and gone, but I always say that dinosaurs are past, but waves are alive and well. And it's really like the opportunity of seeing, it's like, hey, look, Tyrannosaurus Rex is around the corner, and we can go check him out. You want to go, and that's a little bit what these big waves represent to us, is the opportunity to see something that you just don't see, that really doesn't exist until it does, and then when it's gone, it doesn't exist again. So, and that's kind of the magic, I think, about what waves represent, is it's the invisible. Like Susan said, they don't even have science to explain it, and then it's there, sinks a ship, maybe you get to see one and maybe ride part of it, and then it's gone again, and then you're wondering, like, was that for real? And if you're lucky enough to have a picture and it never really does it justice, you just kind of live with the effect it had on you and the experience that it brought you by just seeing it. I always say, to me, I mean, to ride it is to just be more intimate, but seeing it is really, that's just to see it is to be in awe and to be amazed, and then you just want to see it again, and again and again.
So without giving away anything from the book, there is a day that pushed Laird and his tow partner Brett Lickle to the edge of their abilities and their lives. And on that day, from various sources that he won't say it, but I reported around it. There were 100-foot waves and 120-foot waves around, and they were unexpected and unforecast. And I was really struck by, when I was talking to you about that, it took a long time to it was such a traumatic and huge experience for them that it took months for me to actually piece it together. But I think at that moment, I guess what you realized was, just how much more power there was in these when they got to that size.
I mean, and if you don't understand anything about waves, I mean, obviously tidal waves move at jet speed, but as you go incrementally bigger from 25 to 50 to 75 to 100, they just go incrementally faster. And they get faster and faster, and pretty soon they're going so fast that you're kind of, we don't really have material to run away, and their boats aren't fast enough, and we're not fast enough, and we're I always say it's like, ants in a water hose. When they spray ants, they kind of go with the water, and you start feeling like that. You feel real insignificant. You start feeling like, that you're just, that you're in something that's, obviously the ocean and its power, as Susan's explained, is the most powerful, source of energy on Earth, and it's amazing to me how we live in denial of that we go and, part of the reason probably why maybe it's the funding or just in my mind that I never lived at the beach. It's like when I remember when we were kids, we evacuated because I lived on the north shore of Oahu in 1969 when the big swell hit, and we were evacuated at like 3 in the morning, and I remember the police coming and getting in the car, and as I was getting in the car, the waves were washing underneath the car, and then we went up on top of the hill, and the next morning, like there was houses that were pushed across the street, and it was just it was not like nothing that we had ever seen, and you go to the North Shore in the summertime and it's flat, and people go, oh yeah, where are these big waves? And then you see it on a day like that, and the waves are as far as the eye can see, and you just can't really understand the power of it until you see what happens in Japan, or you see what happens, but then it's already too late. Like, you're not supposed to be building nuclear power plants right next to the ocean. It's just, but somehow we just pretend like that's not going to happen. Oh, that's not going to happen. And then when it happens, we're like, oh my gosh, look what happened. And so really this is about that, this is about that. This is about, understanding, our world, and understanding. And I mean, Susan's writing and she's making us, look better than we ever could have dreamed, and we're fortunate to have her, just her. I mean, like she said, 5 years on this book, and I talked to her, hey, how's it going, Susan? Well, I haven't been out of the house in 3 days, and I can't sleep, and Susan, you'll get through this. It'll come to you. You'll make it. I don't know how to make this thing go into this other part, but she's her skill really has, helped shed the light on what's going on, and what the ocean represents, what it's capable of doing, and I think that's part of our job too. Part of our job is to try to ride these waves and maybe help people appreciate the ocean through the respect of it, maybe the fear of it, maybe the awe of it. I'm not sure. Maybe a little of all of it. That at the end, that maybe we'll take a little bit better care, be a little bit more. Just be a little more concerned what's going on, because it's definitely, we're in a time of change, and it's easy to pretend like it's not when we just turn the AC on in a hot building and pretend like, oh yeah, climate change, sure, yeah, no problem. But like Susan said, some statistic about if the ocean surface raises 1 centimeter or some ridiculous amount, that the volcanoes will start erupting like 300 times more often. It's like, I mean, there's just these things that just you don't even realize how sensitive, this little planet that we're on, that is traveling at 26,000 miles through space and spinning around like that with this big ocean. It's and the ocean's us. I mean, we are the ocean. It's and the waves are the ocean, speaking to us, and we get to ride them, and our lives are dedicated to trying to be in the position to ride them and be ready to ride them. But when they finally get here, you kind of have to ask yourself, well, are we really ready to ride them? Maybe we're ready to ride what we can, and then the rest we can just watch and all,
The climate change thing, I know you guys probably deal with scientists, and are scientists, probably also, there are people in this room that are. I've dealt with scientists a lot, because I think a lot of the best stories in nature, science is filled with amazing, miraculous narratives, but often, the same brain that can understand and prove it can't really tell the story. So I spend a lot of time talking to scientists and trying to, my goal is literally to take the most complex quantum physics and chew it down to something that a kindergartner could understand. And what I was surprised by in my research for the wave was, scientists don't often agree on stuff, and when they do, there's bickering and there's dissent even then. I've never seen an issue that unites scientists the way this does, and that has provoked the kind of fear that this has, because we know it's happening, we can't prove it, and it's like the frog in the pot thing. Like, by the time we can prove it, we could be under 120 feet more water. And it's happened before, that they know. But the feedback loops and the things that the unanticipated parts of those feedback loops, nobody really understands. I mean, we only got satellites around 1980, so some of these large-scale climate patterns, they could be thousands of years in duration. Some of them are, even if it was 38 years in duration, we'd still be screwed because we've really only been looking for a nanosecond. So the notion that that somehow that if we just, people will say to me, well, do you believe in it? It's like, who cares if I believe in it? It's happening. I mean, we may be living in the age of the Anthropocene, but if you, if you see a 100-foot wave, you really don't have any doubt about who's in charge. So that was a real eye-opener for me. And I think, if I'd set out to write a book like, hey, this is what you should be concerned about with climate change in the ocean, people would be like, yeah, like I'll get right on that. I'll read that. But this is really a story that kind of depicts it through the characters, and hopefully by the time the book is done, you have a real visceral sense of what the conclusion that I came to, which is we're living in a stormier, more aquatic world, like right now. I mean, right now China's flooding. Right now, the tornadoes that hit the southeastern U.S., I mean, we are in it. And we may not be able to see it in any sort of scientifically provable way until years after, because no one thing can ever be attributed with any certainty, but we're in it.
Well, and then what's amazing is that we have all these things, like in North Dakota, they just had a flood that was 8 feet above the 132-year flood line. And then they have all these things happening all over the world, but then you get one doubter throws in the doubt button, and then all of a sudden everybody's like, well, maybe it's not, maybe it is, and maybe, it's like, but who cares? Because just look at the facts and you see the stuff that's happening. Those things are happening. The tsunamis hitting Japan, the Indo, I mean, all these things are happening. And yeah, they've been happening, but they're happening to us right now. And even if they've been happening, they're going to continue to happen. So why not at least be more prepared and have a better understanding of what's going on, so that we have less of what's going on, less damage, less devastation. That's the big thing, is really forewarned is forearmed. It's like being prepared. Like, let's have a little bit of preparation. Just in the last, it's so funny because in the last 2 years, I lived in California in the summertime. Only in the last 2 years you see tsunami evacuation routes along the PCH. And that's in the last 2 years. I mean, why now? We got a chance. If you live near the ocean, and the water sucks out and you see the fish jumping and it's dry as far as you can see, get in your car and drive as fast as you can to high ground. This is not, it's like, this isn't, rocket science. This is some pretty simple stuff. And don't build nuclear power plants on places where, don't build cities, don't build, the problem is a lot of our habitats are a lot of the populations live in these low-lying areas because it's around harbors and ports and everything that we've developed our world around. But these are the vulnerable areas. This is the areas that are going to be, it's happening, and let's not be in denial of it. Let's realize it's for real.
Yeah, that was people are like, I'll never get on a boat again after they read the book. And the idea behind the book is not to scare people away from the ocean. It's to sort of make bring the ocean more to them, so that, because it all does come down to understanding and respecting and all that. So the notion, and maybe you don't want to read it on a boat, but I don't think it's not really about scaring people away from the ocean. It's about, let's embrace these powerful forces, that surround us, and let's, as Laird said, work with them.
I remember the first few times we were out there, I yanked Laird onto this wave. And this one particular day was really, really big, and he's 6 feet 5 inches. He's huge. And this wave made him look like an ant. And I was just shaking my head at what was right behind him, knowing that if he did wipe out or his equipment did falter, he would get eaten alive. And that's when that so-called Jaws, that image Jaws came in, and I told him, you don't even want to know what was behind you. It was Jaws. It's the most perfect, top to bottom, barreling, deadliest right in the world, and not one other wave comes close.
time, sister, brother, cut to come all alone, built up, level.